Dr. M. Suresh Gandhi is working as an assistant professor in the Department of Geology. He had also served as a faculty for the Center for Natural Hazards and Disaster Studies at University of Madras. He had completed his PhD in Geology, Micropaleontology at Tamil University, Tanjavur. He has specialized in marine micropaleontology and sedimentology. He has 12 years of teaching experience in geology, environmental geology, and natural hazards. He had received D.Sc. Young Scientist Award for the year 2004 to 2008. He is a member for Past Global Changes Switzerland and life member in Gondwana Geological Magazine Nagpur. He had presented more than 50 papers in national and international level seminars and conferences. He had published 40 papers in the reputed national and international journals. He had organized 10 national and international seminars. He has published 2 books on cyclones and heavy minerals. He had completed 7 major research projects funded by UGC, D.Sc. and DOD.
Welcome to UGC lecture series. So, last class we have studied about earthquake, how it is formed, and what do you mean by elastic rebound theory, and also we have discussed about the instrument called the seismograph and different causes. And now we are going to discuss about the role of seismic waves, how seismic waves act during the earthquakes, and then measuring the earthquakes. Then we have to discuss about the destructions of the earthquakes and also different earth layer structures, and finally seismological zones. What do you mean by seismic waves? As I already told, there is a 3 different waves: primary waves, secondary waves, and L waves. Here these 3 seismic waves all traveling through the ground while during the earthquake times, but which waves act differently like that? Now I am going to tell you. For example, if you see this diagram, there is a P waves or compressional waves. So, that means most of the earthquakes occur in the back and forth motions. That times produced P waves will be travel along the surface and can cause the ground to buckle and fractures. So, 3 types of waves. One is called primary waves, secondary waves, and L waves. Here the P waves, you can see this diagram, P waves, that means it is formed during the back and forth motions produced as P wave travels along the surface, can cause the ground to buckle and fractures. Whereas, if you see here in second diagram, mostly the ground is shake up and down. So, during that time the S waves will travel more. And in third diagram you can see here, this is the another type of surface waves traveling along the earth surface, much like rolling ocean waves, and also the motion follows the shape of an ellipse. So, that is way this seismic waves will be acting during the earthquake times. For example, rope, if you take a single rope, you can slightly shake it from one end, then what happen? The waves will be generated. You can get first wave, second wave, third wave, like that. So, that is named as particle motions. So, the waves coming in one side and going down, and again it touches the rope. So, that is called the wave directions. This way the S waves and transverse waves can travel. So, like that. Another is zigzag motions. Here the one type of surface wave actions, surface wave moves the ground from side to side and can damage the foundation of buildings. So, this way seismic waves is acting. And also all of you know that fault is also one of the important properties for the formation of earthquakes. As I told earlier, you have a different types of fault. One is called normal fault, one is called abnormal fault, that means reverse fault. Then another one is called transform fault, that is zigzag motions. Here in normal fault, the foot wall will be at one place, hanging wall is moving down. In another case, reverse fault, the foot wall is going down, hanging wall is at one place. You can see here in this diagram, normal fault, the foot wall is at one place, whereas hanging wall is going down, whereas in reverse fault you can see the foot wall is one place, the hanging wall is going up. If it is in a zigzag direction, we call it as strike slip fault. So, most of the earthquake occurred while during the strike slip fault conditions, mostly in the strike slip fault conditions. There are also lateral normal fault and also lateral reverse fault is there, and we also measuring the earthquakes. How means, as I already told, with the help of waves. So, first waves coming, which wave will coming first and which wave is coming second, like that we have easily measuring the earthquakes. So, based upon the earthquake waves, we can easily find out the earthquake distance, from which distance the earthquake will occur. For example, all of you know the place where the earthquake is occurred, that is called focus. Then above the focus we called as a epicenter. So, the epicenter is located using the differences in the arrival time between P and S waves recordings, which are related to distance. Earthquake direction, that means travel time graphs from 3 or more seismographs. As I already told, seismograph is located in different locations, not only in India, in the entire world there is a instrument called seismograph. They already fixed in a ground motion. Whenever small slight jerking something is happened in the earth, automatically the seismograph will start the readings. So, that seismograph is permanently fixed in all the places. From that seismograph we can easily find out the earthquake places and which distance the earthquake will occur, like that. Here I can told, here you can see here the earthquake direction, that means time travel graphs from 3 or more seismographs can be used to find out the exact location of an earthquake epicenter. For example, you can see here, this is the epicenter, that means one waves travel one distance. So, they have measured one diagram. From in another seismograph they have recorded this diagram, from another seismograph they have record this diagram. Then finally, all the 3 point meeting at one place, that place is called epicenter. For example, here it time travels, it will take 5500 kilometers for travel distance. From here it is 8400, like that here 6700. So, all 3 meeting points is called the epicenter. So, below the epicenter the earthquake will be occurred. From that they have easily find out the, based upon P waves, S waves arrivals, and also with the help of triangulation diagram they can easily predict the location of the earthquakes. And also scientists, they find out the earthquakes and then they have measuring the earthquakes with the help of scales. Generally they use intensity and magnitude. So, both these intensity and magnitude is very much useful to measure the earthquakes. And also one scale is there, we called as Richter. He is the scientist, he proposed the magnitude and intensity scales. Based upon the magnitude he calculated how much damage or destruction will be occurred. So, based upon that he modified the scales. So, for his name only they called as Richter scale. Nowadays it is modified, we called as modified Richter scale. Here magnitude, so they are derived from amount of displacement that occur along the fault zone. So, how much amount the displacement is taking place, and also magnitude is the most widely used measurements for earthquakes, because it is the only magnitude scale that estimate the energy released by the earthquakes. So, measures very large earthquakes. You can see this diagram, for example, magnitude generally not felt, but can be recorded. Some place some earthquake will be occurred, but we cannot feel anything. People simply told as slightly shaking, some changes will feel like that. So, that means very less magnitude will be applied in that places, whereas in some place people can feel severely for 1 minute also. Some fan will be changing the directions, not only that table will be fell down, glasses will be broken. So, like that some feelings will be occurred before the earthquake and also during the earthquakes. So, finally, they have measured the magnitudes. For example, if it is less than 2 means no feeling, there will be no feel at all, nobody can identify it, but earthquake is there, minute earthquake will be there, but we cannot feel anything. Whereas, it is up to 3, for example, 2.9 we have a potentially perceptible slightly, and also this type of earthquake occurred continuously. You can see here more than 6 lakhs times this type of earthquake will occur, that means less than 2 percentages of magnitude, but we cannot feel anything. That indicates our earth will be shaking continuously. And also 3 to 3.9, that means rarely felt, we feel light slight feeling. During in case of sleeping time we cannot feel anything. Again during 4 to 4.9 strongly felt, severely affected, chairs will be dancing here, moving here and there, like that. Even our computer systems, monitors, everything will be shaken. So, that also one of the magnitude, for example, 4 to 4.9, and also up to 5.9 damaging the shocks will be appeared, and 6.9 destructive in populous religion, and 7.9 that is the major earthquakes. In case of above 8, that is the great earthquakes destroy the communities near the epicenter. So, not only that, this is the intensity scales with respect to magnitudes. For example, they have the scale is numbered in numeric 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, 12 numerical scales. In case of 1, that is very instrumental, and also in case of 9 it is erroneous, in case of 12 it is catastrophic. So, like that they have classified the earthquake scales, and also measuring the size of the earthquakes, that is intensity measure and also magnitude estimates. So, intensity means measure of degree of earthquake shaking at a given locally based on the amount of damage, whereas magnitude estimates the amount of energy released at the source of earthquakes. Again you can see here, these are all over the world. Some earthquakes occurred, mostly all you can see the magnitude values all are above 6.5. So, that indicates there is a severe damage. So, major damage, and also we classified the earthquake into 3 zones: shallow earthquake, deep earthquake, and also deepest earthquakes. In case of shallow earthquake means the depth is very less, 0 to 30 kilometers, and in case of in between the earthquakes then 30 to 100 kilometers, like that. Then deepest earthquakes means below 100 kilometers. So, most of the earthquake in shallow, like for example 0 to 30 kilometers, you can notice a severe earthquakes. So, most of the earthquake occurred in the shallow means damage will be more, whereas in case of deepest earthquake you will get very less damage. For example, in shallow earthquake what happened, wherever the earthquake occur, immediately the energy will be released, automatically you can get more destruction, whereas in case of deepest earthquake you can notice very slight damages, because of automatically the energy released inside the earth, it will while it coming out time, that the time interval, that means the time gap will be reduced, automatically the energy will be also reduced while it coming outside. So, like that you can see here most of the magnitude above 6.5. So, you can get more damage. So, seismic vibration also more. What we mean by seismic vibration means wherever the earthquake occurs, the waves will coming out automatically, we call as seismic waves. So, what that vibration, how much vibrate will be acting in that earthquake places, we call as seismic vibrations. So, damage to buildings and other structures from earthquake waves depend upon several factors. These factors include the intensity and duration of the vibrations and nature of the materials on which the structure is built and the design of the structure. You can see the damage after the earthquakes, huge amount of buildings simply collapsed, like that building designs. So, the factors that determine the structural damage mainly intensity of the earthquake, unreinforced stone or big buildings are the most serious safety threat. So, wherever earthquake occur, we have to take some precautions also. We have construct a house with safe mode. Otherwise, if you construct the house with the bricks and the heavy hard concrete means automatically the vibrations will be more, the building damages will be more. So, depending upon the earthquake waves generations, we have to modify our building construction also. We have to construct with light materials and also like some pillar method construction, that is very safe for prevention during the earthquakes. So, with this I will give a break and I will continue afterwards. Welcome back to our lecture series. So, as I already told how the construction of building is made, not only that, suppose during the earthquake before the earthquake, what happened, some liquid will be coming out, simply we called as that type of liquid is coming out up to 1 to 2 meters in most of the small crack places. This type of liquid you can easily observe in the Japan countries, very black color and slightly hot water like liquid substance coming out before the earthquakes, that is nothing but simply we called as liquefaction. Here you can see here liquefaction, saturated materials turns fluid. This is the underground objects may float to the surface. So, that liquid what happened, they can easily take the building away. So, building will be float in that liquid, that much of power as having this liquefactions. And also unconsolidated material saturated with water turn into a mobile. So, liquefaction on the ground, that is mainly effect of the earthquakes. During the earthquake, liquefaction is coming out automatically, the unconsolidated materials. In geologically we have different types of materials, consolidated materials, unconsolidated materials, like that. So, here unconsolidated materials, the saturated water turn into mobile fluid. For example, you can notice in San Francisco Bay there is a saturated sediments, a great deal of damage occurs as a result of liquefaction. The features called mud or sand volcanoes, simply liquefaction is nothing but mud like substance, otherwise a sand volcanoes, simply we call as sand volcanoes. They can easily take the building away and it will be movable nature, automatically the building can move slight distance. So, that much of power is having for liquefaction. Another term SEICHs, SEICHs, that is called SEICHs. These are the rhythmic sloshing of waters in lakes, reservoirs and enclosed basins. Like whatever liquefaction, another term is called SEICHs. The waves can weaken reservoir walls and cause destruction. This also one type of earthquake affect activities. Then now coming to the groundwater earthquake, after the groundwater liquefaction studies, now we are going to see about earthquake destructions, mostly ground ruptures. So, what happened? The land splits apart, automatically the land surface splitting apart and causes the ruptures. For example, land shift. Land shift is the uplift of the sea floor, which has been known to occur during the earthquake. Automatically the sea floor or even the land surface or even the continental surface, it will be moving up and down, simply more or less similar to tectonic activities, plate tectonic activities. Like that, the earthquake movement also causes severe effects. You can see here one diagram how the land will be subsidized due to liquefaction. So, below you have a liquid. Why this liquid is coming? Already I told, suppose two plates collider, what happened? Whichever denser plates that is going down, the weaker plates will be float up. Once the denser plates going down, it touches the upper part of the mantle where more heat energy will be generated, and automatically the volcanic gas materials will coming out through the volcanic vent and other extrusion materials. From that some liquid will be coming out. So, that type of liquid is only we called as liquefaction. Due to the high pressure and mobile nature, automatically you can see here this building, the entire building is pulling out and slide down. Not only that, the earthquake, most of the earthquake occurs in the land, not only in the land. Nowadays you can notice the term tsunami. That means what? Some earthquakes occurred inside the sea also. So, once the landslide occur in the sea, automatically it will affect as a tsunami. So, how tsunami means? A tsunami triggered by an earthquakes occur where a slab of an ocean floor is displaced vertically along the fault. Here again I can already told different fault. One fault is called normal fault, one fault is called reverse fault, and another one fault is called strike slip fault. Here what you noticed, due to normal fault itself or even strike slip fault. In normal fault what happened? One place is as such, then another wall, for example foot wall or hanging wall, either one going down or up, what happen? Automatically the huge amount of water will going back and remaining water in opposite direction, flowing in the opposite direction with the speed, heavy speeds. Then while it coming to the shorelines, the speed will be reduced and the wave of water will be increased. Then all the remaining waters drain to the land area, then again it recede back. So, that is the simple terms for tsunami. So, this tsunami occur when the vibration of earthquake sets an underwater landslide into the motion. Tsunami is the term made by Japanese, also called seismic sea waves. You can see here, this is the fault zone. Here displacement occur in one type of fault, either normal fault or reverse fault, and any one of the fault. Automatically what happen? One block is going down and another block is going up. Automatically due to the upliftment, the huge water wherever here it is going back, and this side the water will be traveling very fast. Near the earthquake you can get the 835 kilometers per hour, that is the tsunami speed. Then up to some distance, and also the depth of water is also reduced. You can see here 340 kilometers, and finally the water depth is 20 meters. Again the tsunami speed is reduced, but the wave will be increased. So, like that it will affects. So, earthquake affects not only in the land, it can affect on the onshore also. So, nowadays people have precaution method for tsunami also. So, that means they have construct or say they have built a instrument called tsunami warning systems, that is the large earthquakes are reported to Hawaii and Pacific areas, they have construct the seismic stations. So, with the help of seismic stations, whatever waves or any undisturbed will occur, it will be easily recorded. From that record they can easily find out whether it is tsunami or simple earthquake, like that. So, tsunami travels quickly, there is a sufficient time to evacuate all, but the area closest to the epicenter. For example, tsunami takes place in Andaman, that means here in Indian tsunami warning system they give some alert. So, we have some little time is there, wherever earthquake occurred in the ocean sides, once tsunami will started means we can easily evacuated or excavated from that place to the higher levels. So, that is one method to prevent our life. So, that is the warning systems, tsunami warning systems. And other destruction in the earthquakes, not only tsunami, we can get landslides also. So, most of the earthquakes, what happened? Greatest damage to the structures, that is it forms the landslides and ground subsidence or sinking on the ground triggered by vibrations. So, due to the earthquakes, the hilly areas and other places easily landslide will be occurred. And also fire, for example, in San Francisco earthquakes during 1906, most of the destruction was caused by fires that started when gas and electrical lines were cut. See, you can see this diagram how the land will be subsidence, landslides due to the earthquakes. And also we have predict the earthquakes, short range prediction, long range forecast, like that. In short range prediction of earthquake have not been successful. So, that is very difficult. Suppose we cannot know when earthquake will be come. So, it will happen immediately itself. Why? Because wherever already I told plate will be moving, plate moving is a continuous process, there will be no stop methods. So, plate moving in different direction in all the times. So, you can easily get earthquake and also tsunami, like that. So, in case of earthquake occurred means immediately we cannot predict it. So, at least we can save. How we can save? That is called long range forecast. That means scientists do not yet understand enough about how and where the earthquakes will occur to make accurate long term predictions. Only with the help of some warnings we can easily predict the earthquakes. At least we can save based upon the earthquake warning signals. So, seismic gap is an area along the fault where there has not been any earthquake activity for a long period of time. So, that is one thing. So, based upon the seismic zones, our India classified into different zones. For example, you can see in peninsular zones, there is a zone 1, zone 2, zone 3, zone 4 and zone 5, like that we have classified with the help of the earthquake destructions. With this I will conclude my lecture, and today we are studied about the seismic waves, earthquake safety rules and also effect of earthquakes and seismological zones. Now, I would like to ask few questions. Explain Moho and shadow zones. What do you mean by tectonic plates? What is magnitude and intensity? Explain the seismological zones. Explain the effect of earthquakes. Thank you.